All right, so periodic functions. Nice thing about this year compared to last year is last year we did this at the beginning of the school year, which not having known anything about sine and cosine graphs definitely made this a lot harder. So periodic functions, they're like sine and cos, where they're this constant, constant thing happening over and over and over and over again. And there's a period that shows how long it takes to make the one complete curve, the one complete wave, the one complete whatever the thing may be. So if we look at this first graph, if we pick a spot right at x equals 0, there is our one complete curve. So our entire curve happens in, 4 units. So what is the fundamental period of f? 4. And what's nice about this periodic function is that it's continuously going around and around and around and around. So we don't need to find an actual equation to figure out what f of 99 is. What we can do here is this. If I divide 99 by 4, our period, so I got 2, 8, leaves me with 1, 9, and multiply by 99 times 16, 4, leaves me with 3, and I have 3/4. So in this scenario, I am left with 3/4. And that's telling me that 99 is on the 3rd spot out of the 4 spots that we have. So spot 1 is 0. Spot 2 is 0. Oop, my bad. Spot 1. Spot 1 is 2. Spot 2 is 0. Spot 3 is -2. Spot 4, which is back to 0, is 0. So in this scenario here, since it's a 3 out of 4, we go with this, which tells us that f of 99 is -2. So if we did f of 50, right? 50 divided by 4. 1, 4, 10, 2, 8, 2 out of 4. So if we're looking at the second spot out of 4, f of 50 is 0. And this consistently will work over and over and over again. You don't need to find an equation. We could just work with the scenario that we have. All right, amplitude. So we know amplitude. That's how far and above we go with our midline. So for this graph, we look, our highest point is at 2. Our lowest point is at -2. So if we go max minus min divided by 2, our midline in this situation is, well, our amplitude in this situation is 2. Our midline is 0. So if we have our midline at 0, we're going 2 above and 2 below the midline. Now what happens with this 2 in the front here? This is called the vertical stretch. It is taking the graph and stretching it out in both directions. So we are basically doubling our amplitude. So by doubling our amplitude, our new amplitude is 4. So where we used to be going 2 above, now we're going 4 above and 4 below. So the fundamental period is not changing, right, but the actual height of the graph is changing. Now that's definitely not perfect. If I were to fix that for a second, we should have it be going, let's see, to there, to there, there. Yes, that's better looking. That last one's terrible, but the idea is the graph is stretched in both directions because we're doubling our amplitude. All right, changing the period, right? So we know that there's B, right? So we know back from our previous unit that the period was 2 pi divided by B. That was something we had back in the day. In this situation, since we're not talking about sine, we're not talking about cos, we got a little bit of a modification to this. So the period is always P. But now to find the modified period, which is called a horizontal stretch, B divided by P gives us, we could say the new period. So for our original graph here, the period is 4. But if we take 4 and divide it by half, our new period is 8. So this graph is stretched, it's pulled apart and stretched further. So everywhere where there used to be think about, I guess if we go with this. So if I have 0, 0, if I have 1, 2, if I have 2, 0, and I have 4, 0. Oops, skipping things. 3, -2, and 4, 0. All right, so in this scenario here, we stretch this graph to the right. So I'm going to double all my points. So this is 2, this is 4, this is 6, this is 8. So I'm stretching it to the right. So that 0, 0 stays, but now I have 2, 1, 2, 2. I have 4, 0. I have 6, -2. I have 8, 0. So in the space where it used to be 2 curves, now we only have 1 look. Right, so there used to be 2 periodic function, curves within there. Now we have just 1. And obviously it continuously goes in both directions, but that's what we have in that scenario. All right, translating the graph. All right, so again, going back to our vertex form. All right, so vertex form, y equals a, x minus h squared plus k. There's no difference here between this and what we've always done. So what is that -2 telling us? This tells us 2 to the right, and this 3 tells us 3 up. So if we make our chart again, 0, 0, 1, 2, 2, 0, 3, -2, and 4, 0. All my x values are getting shifted 2 to the right. So I got 2, 3, 4, 5, 6. All my y values are getting shifted 3 up. 3, 5, 3, 1, 3. So I've taken the entire graph and moved it over there. So I got 2, 3. I have 3, 5. I have 4, 3. I have 5, 1. I have 6, 3. And again, this is continuous, so it's going on and on and on and on and on. So it's not a set thing. So if we have, in this case, 2, 0, right, that also means if we go back the other way, right, now our midline's at 3. We're going above and below our midline. Right, so if I have 2, 0, that means in this situation, I would have I would have 1. So I'm going 2, 3, 5. I'd have 1, 1. Right, so the graph would continue on. Right, then I would go back up. Right, I'd have 0, 3. And we continue on, -1 up to 5, and so on. So the graph is not just that little spot that I placed it. The graph is continuous. So I use these XY table to kind of help get exactly where I see it. But overall, I shifted the entire thing right 2 and up 3. Okay. What is the fundamental period of this graph? So if I look, my entire graph is from there to there. There's my situation. My period is 4. My amplitude is a half. Why? I'm going from 0 to 1, so the middle, is going to be at a half. I'm going half above that, half below that. So if I go f of 25, 25 divided by 4, 25 divided by 4, 20, I have 6 and 1/4. So if I go at the first spot, f of 25, which is the first spot, is 1. If I had f of -25, All right, so I got negative 25 divided by 4. It goes in 6 times. So I subtract 24. I got negative 1 now, so I got negative 1 out of 4. Well, negative 1 is not really in our wheelhouse. So what I'd like to do here is just, if I add 4, so I got negative 1 and I add 4, because it's continuous, just by 4s, by 4s, by 4s. Negative 1 is the exact same spot as 3. And if we look on our graph, negative 1's right there, and 3 is right there. They both have the exact same consistent value in this scenario. So whether it's f of negative 1, f of 3, or in this case, f of negative 25, it's going to be 0. Okay, sketch the graph of 2x. 2f of x. So what does that mean? We are doubling its height. We are increasing its height in this scenario. So we're going up to there, 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 there. So my graph looks like this. All right, and we're pulling it off that x-axis. Now, if this was below the x-axis, this would change exactly what's going on. But since it's all above the x-axis, we're just pulling it vertical. All right, so if I go with the f of a half of x, all right, that means my period is going from 4 to a period of 8. So where it takes 4 seconds to complete the curve, it's going to take 8 seconds now. So I got 0, 0 locked in. I got 2, 1. And I'm going across for 2. And I'm going down for 2. And then I'm going flat. All right, so there is my 8-second curve. And it's continuous, but I drew one piece of it. All right, f of x minus 3. So we drop the entire graph down 3 units. All right, and last but not least, f of x plus 1. That means move the entire graph left 1. One unit over. And there's our graph.